In this video, I'll be talking about the Gatorraider project, how to set up the project, as well as some advice on tackling the project and moving forward. So I'll split this video up into 7 parts. The first part is obtaining the code base. The second part is setting up the project inside IntelliJ. The third is showing the run options. So this is important. This will be able to test your code to see if it runs, as well as be able to see the visual components of your code. Four, we're going to explain some project details, so some specifications within the project document. Fifth, student code requirements. So if you are submitting this project for a grade, some requirements necessary to make sure you meet the specifications. Six, we'll talk about the classes used inside the game, basically categories and methods, and which methods might be useful to you, as well as how to split them into the categories that make sense to you. And then 7, we'll go over grading. So if you are submitting this project for a grade, basically what the grading procedures are. So we can get started with obtaining the code base. So to obtain the code base, you should have a PDF document like the one right here. This is the document that basically you'll read off of. So at the very beginning, it tells you an overview and then getting the code base. So if you click the link right here, it should bring you up to a page right about here, a GitHub page that has all the things that's necessary for you to get the project started. If you know how to use GitHub, you can basically clone the link. Otherwise, you can just download the zip. You can download the zip right here, and it should download. So I already downloaded it, and let me see here. So as you can see, it'll show up as a zip file, and if you click it, you can extract all right here. And so once you extract it, you should have something along this line. So a file that says Gatorraider master. So you click it and you can see all the files in here. One thing to note though is that you see this file right here. If you click in, you see there's another Gatorraider master. Make sure you get the inside one, which means that if you click that folder, inside is the file. So not this one right here, but this one right here. And so you can pull it to wherever you put your projects, in this case, idea projects. And then after that, that's all you have to do within the folders. Make sure it's under idea projects. It's a separate project. Make sure you don't put it within any of these SRC folders. Make sure that it's within just under idea projects in the separate projects. After that, you can set your project up in IntelliJ. So if you open up IntelliJ, it'll show you code and different stuff. So when you basically import the project, you want all the settings that we give you. So if you go to File and then you have Open, you should see a bunch of different files. So basically, usually you'll go into your C drive and then your users and then your username, and then perhaps in this case, we'll go to Idea Projects. So let me close this, and then you'll see Idea Projects there, right? And then you'll see Gatorraider, and you also see this little black icon right here that's not in the usual folders. Make sure that icon is there. You can click down just to see that all the folders are set up. Once you click there, click OK, and you can put in whatever. I'm going to put in new widow, and it should show up. One of the first things you should check is that you have all these run options. So there might be some red, but it should show you some run options. And then also, it'll ask you that your SDK is not defined. So we're using Java version 8, and so you can just click into Java version 8, click OK, and then everything should be set up that way. Yeah. So once you get to this screen, everything should be set up for you to run. There's a lot of different run options right there, and then you can see your SRC folder as well as all the folders all the files that you need. So if we go back, we basically obtain the code base, we set up the project, and then I'm going to talk about the run options. So for the run options, you can see a lot of run options here. The main ones you'll use are test agent visual and test agent score. Test agent scored is to see the average score of 100 simulations, I believe, and then test agent visual is to basically see the visual component or the visual game of whatever you coded. For this, since we just imported it, I'll just show you the example visual. So if you click that and you press play, what should pop up is a little window right here that shows you the visual game of Pacman, or in this case, Gatorraider. So it's building classes and compiling everything. All right. So while this builds, let's look at what else we have. So there's a couple of things about the project as well as code requirements. Um, and we'll go into that right after. So it seemed like it's running, so it usually takes a while. So you can see here, this is the game running, and this is the example we have that's given to you, so you can run this inside your own. And so if you have test agent visual, as you can see, if you have test agent visual, it should run the same thing, except this Gator right here is controlled by you, by your code. Um, for I believe, test agent, for example score, you should see the score or the average of all the scores for this specific AI right here, and then you can just see as it died. This shows you the visual component. So besides that, we'll go into specification details. The first we'll see is that you have all these different things. The first part is talking about Pacman. So if you never played Pacman before, you can read all this. This should be very helpful. All this tells you the different modes of Pacman and how it's scored. Here you can see the project structure. So what this is saying is that you have your controller or your AI right here, and then you have basically the data itself, and then you have what you see. So controller, which is you, sends data to the model, and that model sends all that data to the view, and then you can see everything play out. A couple of things. The first thing is that you should only be altering code within the attacker controller interface. So if you open up your project, you see 3 files right here. 1, 2, 3. You should only be altering the student attacker controller, none of the other ones, just student attacker controller for this project. The second thing is that you'll have three methods, and those are the ones where you can alter code in. The first one is init. This basically, the code executes at the very beginning of the game, not during or after, only at the very beginning. The second is shutdown. That executes at the very end of the game. So for both of these methods, you can leave them empty if you don't think it's useful. But finally, you have this method called update. Make sure that you do have code inside here. So this updates every frame. I believe it's milliseconds. And so it basically tells the robot where it's going to go next. So make sure you have code inside here. This is the main method that you'll write all your code in. Other than that, so student wrote code requirements. There are requirements in the PDF that you can see. So stuff like this. Make sure you read those. Stuff like the init shutdown may be optional empty. That you must use information from the state, the board state, and maze, as well as the attacker state to make decisions. You can't have random decisions, and there's just a couple other things that you want to make sure you read. So after that, you'll get into basically all the methods and their definitions, a description of their definitions at least. And so we're going to go over the different method categories that you'll be using. So as you can see right here, there are 6 categories of methods. The first is game interface, second is node interface, the third is maze interface, actor interface, attacker, and defender. So hopefully this gives you an idea. I'll explain this. So the game interface basically gives you information about the current board state. So what pills are left. So pills are the little white things that the Pacman eats or the Gator eats. It gives you the basically current state of the game. The maze gives you basically what the terrain looks like. So getting initial defender positions as well as other things. So you can see that there. So maze gets the terrain, getting initial, getting pill nodes, getting power pill nodes, and junction nodes. The reason why they all point to this is that they all use the node interface. So the node is basically like your XY coordinate, and this tells basically locations on the screen, and it tells you where there might be pills. So a pill might be located at a specific node. So if you look at that, you should be able to see what a node is. So for example, get X, get Y, and then see if a specific node has a pill. So is pill. Um, so that should take care of the game and node and maze interface. Then we go to the three actor basically interfaces that you'll need to know. So actor is the overall class. The attacker and defender uh, extend the actor interface. So that means that all the attacker methods are available. All the actor methods are available to the attacker and defenders. And so the methods that are specific to attacker cannot be used by defender, and the method specific to defender cannot be used by attacker. So for example, let's say that for actor interface, we have something called get location, right? An attacker can't get the location. The attacker can also get direction. It can use all these methods. And right here, there's two methods. So these are specific to attacker only, which means that only the attacker can use these methods, so the defender cannot use these methods, and a general actor cannot use these methods. Then we have the defender. The defender has specific methods to itself. It can also use all the methods up here that relate to the actor, but it also has methods specific to itself, such as is vulnerable, requires action, and get vulnerable time. So make sure you read the different specifications or its descriptions of the definition so you can understand what you're doing there. And then after that, let me see here, grading should be very straightforward. Um, if you look in the PDF document, grading tells you how it's split. So only 40% of it will be your average score or your overall score for the Pacman. There will be 30% on the criteria, so make sure you read the PDF. Then there will be 30% on the document. So right here is the document description. Make sure you write a PDF of that and turn it in with your submission. Besides that, that should be most everything that you need for the game. I'll give you a couple pieces of advice. The main thing is that you are writing code for the brain of the Pac-Man. So basically, when the Pac-Man moves where. So make sure you have a strategy. I'm going to split. I usually want to show you how I would split this up, and then basically if you want to use the same style or the same idea of strategy, you can do that. Otherwise, you feel free to do everything within the project specifications. So usually there are three categories. The first is getting data, and then the second is analyzing that data, and third is making a decision. These are the three parts necessary to get your Pacman running. So up here, this code you should have from the very start, and this we can basically break this down to those three steps, right? This first thing right here is to get possible direction. So that is getting data. So getting data is often using these three methods or these three interfaces, the node interface, the game interface, or the maze interface. This will help you get the data. Make sure that you, if you can see here, this is getting the data. And then we're analyzing that decision right here. We're saying if that, basically, if it's not equal to 0, then we get action or where we're going. And after that, we return the action. So analyzing that data means that you can probably use if else statements or for loops. Making the decision, perhaps you want to use if else to prioritize your different strategies, and then make sure that you return action, which is a integer that tells you which direction you should go. Hopefully that gets you started on how to tackle the project. Besides that, if you have questions, feel free to ask your TAs. And if there are any other questions that you have, I'll try to maybe in the future answer those questions. Besides that, good luck on this project. Hopefully it's very interesting for a lot of you, but best of luck on this project.